induced magnetism. We can make something into a magnet. We can make something into a magnet, something that means material which is, responding to magnet. But it is magnet only for the time we have another magnetizing field. एक object है. If there is one object, if we place it in a magnetic field, this becomes a magnet. We remove this field, this loses its magnetism. It is no more magnet. So magnetism is induced in this only when we bring in a magnetizing field. So there are places where we require permanent magnet. There are places where we require induced magnet. For example, alternators of the motorcycles. जब इंजन को घुमाते हैं तो उसमें एक मैग्नेट घूमती है, कॉइल बाहर में रहता है, यहाँ कॉइल के भीतर में मैग्नेट घूमती है, देन इलेक्ट्रिसिटी इज प्रोड्यूस्ड, उससे आपका बैटरी चार्ज होता है, 12 वोल्ट की बैटरी चार्ज होता है, बत्तियां जलती है वगैरह. सो दैट इज परमानेंट मैग्नेट. जितने दिन बाइक चलती है, 20 साल, 10 साल, 15 साल, उतने दिन वो मैग्नेट बना रहा है, परमानेंट मैग्नेट. अदर प्लेसेस, द सेम बाइक इफ यू टेक, यू हैव अ स्टार्टर स्विच, आप पुश बटन दबाते हैं, अगर किक वाली नहीं है, सेल्फ वाली है, आप बटन दबाते हैं तो इंजन घूमता है. कैसे घूमता है? विद दिस पुश बटन वी ऑपरेट अ रिले. जैसे ही हम बटन दबाते हैं तो ये कॉन्टैक्ट बनता है और कॉन्टैक्ट बन करके सप्लाई जाती है मोटर को, मोटर घूमता है, इंजन को घुमाता है. सो डिफरेंट प्लेसेस, डिफरेंट यूसेज ऑफ दिस. Why we are talking about this? We are not going to use permanent magnet or induced magnet. We are not using it to make something. We are talking about this only because the compass is going to react to this kind of magnet. When the ship is having this compass, and if there is a magnet around it, either induced or permanent, then the compass will get affected. Why will it get affected? Because ultimately a compass, magnetic compass, is nothing but a hung magnet, permanent magnet. It is suspended in one way or the other, that it is always pointing to a given direction on the earth. We also talked about the 3 types of materials. Substances can be, categorized from different points of views based on different requirements, their chemical properties, their electrical properties, their magnetic properties. So here we are trying to talk about magnetism. So from the perspective of magnetism, substances can be described or categorized as, yes, please, what are the types of magnetic materials? कल बात हुई थी. Yes.
Ferromagnetic material.
Paramagnetic, diamagnetic.
Para and diamagnetic.
Correct. And we also understand the behavior of these 3. Ferromagnetic material can be easily magnetized. They respond to magnetism in a very, very nice manner. Very quick, very easy to be. They respond to magnetism. Paramagnetic material, they respond to magnetism but very slowly. They get attracted. Yes, if this is the magnet, a paramagnetic material will be moving from weaker field strength area to the stronger strength area. Diamagnetic, on the other hand, will be repelled back. So these are the 3 types of magnetic material. We are not much bothered and concerned about the para and diamagnetic material. For one thing, there is not much of it on the ship. If it is not producing so much of effect on the compass. So para and dia can be left alone. What we are concerned about is the ferromagnetic material. Now the whole ship is made up of steel, which is a ferromagnetic material. Iron responds to magnetism. शुरुआती वहीं से देखा हमने magnetite Fe3O4. So the whole ship is built up of steel. The hull plates, the decks, the cranes, the structures, accommodation, everywhere it is steel. So this steel is either going to be a magnet in a permanent way or in induced way. So we are now going to talk about the magnetism of the ship, how it is developing and how it is going to affect the compass. In concept, I think I want to repeat this, but in concept, we also discussed, I suppose, that magnets are defined by the two poles. Any magnet has got two distinct poles. One pole is termed as red pole, the other one is termed as the blue pole. The red pole is what it is called, north or south pole. Red pole is what?
North.
North. Why is it called north pole?
Because sir, the south pole of the magnetic get attracted towards it.
Because the south pole of the
Because the red is aligned itself in the north of the Earth magnetic.
north of the geographic north of the earth.
Geographic north, but Earth magnetic is south actually.
Yes, earth का south. So we also discussed कि earth में molten state में liquid form में iron होती है, वो उसका churning and then there is lot of electricity being produced. Because of that, earth is also producing a magnetism, which is basically a shield for us. It protects us from so much of radiations coming from the space. If this magnetism was not there, then we would have been fried by the bombardment of various kind of rays coming from the universe. So it is kind of protecting us, and it is making also us allowing us to make use of its magnetism to find out direction. So there is blue pole and red pole. With respect to this magnetism, we'll go to the board to talk about few of these things. Just one second. Just one second. Let me. चलो ठीक है. सेट करने दो कैमरा. Please hold on. All right, so board is visible.
Yes, sir.
All right, so what we are saying, that there is a magnet. One end is red, the other end is blue. If we draw the center line, these poles are equidistant from each other. This side of this is called broadside position. So this and this are broadside position, perpendicular to the axis. This is the magnet axis. And in line with this side is called end-on position. The magnetism of the magnet, why it is called a magnet? Because if there is a field existing outside, there is an area which is existing outside the magnet, then we call it a magnet. That means if I keep a nail here, it gets attracted to this. Why? Because in this open space, there is an area which is exerted by a force created by this. So this area where a magnetic material is experiencing some kind of force is called magnetic field. So this magnet has got a magnetic field extending around it. These fields are represented by these lines, what we call the magnetic lines of forces. These are called magnetic lines of forces. These are imaginary lines, not that it is existing, not that it is not existing, not that it is in the form of lines or not, but we have taken the help of these lines to explain the phenomena. These lines are parallel to each other all the time. They never cross each other. They never cross each other. They may be affected by another field wherein their shape may change. Their shape may be changing if there is another kind of magnetic field or force. But again, they will remain parallel. So these lines of forces are called magnetic lines of forces. These are used to express the magnetic field. Lines of forces are coming out of the red pole, the north pole, and going into the south pole. All these all these lines are understood to be coming out from the north pole and getting into this, but that is outside. Inside, it is in the opposite direction. So all these lines of forces are continuous lines of force. Within the magnet from south to north, outside the magnet from north to south. Then how to describe this area? What are the features that we can talk about it? These lines of forces are very close to each other in this closer area. As we keep on going out, there is the lines of forces become wider and wider and wider. I think that gives us a feeling that the effect of the force will be here more than it is here. since the number of lines of forces are more in this area, closer to the magnet, it is, I think, a common sense feeling that the strength of these lines of forces will be more closer to the magnet and less here. If you are feeling so, you are very right. So how do we express this? How strong it is, or how not strong it is? That can be talked about by another term. There are various terms which are used in connection of this. One is the flux. These lines of forces, what we have already said, these lines of forces is termed as flux. And the difference between the lines of forces in a unit area is called flux density. So flux is the number of lines of forces. Now lines of forces in a given unit area per square meter maybe. So how many lines are passing in a unit area here, and how many lines passing here in unit area here are the measure of flux density. Field strength H is a function of the flux density. Flux density is more, the field strength is more. Flux density less, the density is less. What happens if I try to bring a magnetic material here? I bring in a piece of iron here. I am bringing a piece of iron here. What is observed that the lines of forces are trying to pass through this more here than it is outside. So more number of lines of forces tries to pass through this material. If I bring in a wood, that does not happen. वुड के केस में चूंकि ये नॉन मैग्नेटिक मटेरियल हो जाएगा, so the tendency of the lines of forces to pass through this material, all of them get concentrated into this. Not all, but most want to try to pass through this. That is termed something as permeability. This is the permeability of this material that makes all these lines of forces intending to pass through this. So it is more permeable. So permeability is another term which is used. These are few terms which will be required, not required necessarily, but this will give you an understanding of magnetization. One thing which is observed, talking about the field strength, हमने देखा कि इसके नजदीक में फील्ड स्ट्रेंथ ज्यादा होती है, जैसे जैसे दूर जाते हैं फील्ड स्ट्रेंथ कम होता जाता है. Why? Because number of lines are becoming less and less. That means flux density becomes less and less as the distance is increasing. We have also seen that we call this broadside position and end-on position. It is observed that from the axis, on the end-on position, if it is the field strength is X, for example, at a distance away from the axis, then at the same distance away from here, the field strength will be 2x. That means the field strength is twice on the end-on position as compared to the broadside position. If I keep a nail here at this distance, it is going to be pulled here by some force. If I keep here the same needle here at the same distance away, again it will be pulled, but the force exerted here will be twice than it is going to experience here at this place. Talking about this magnetism further, if we have a magnet, we have a red pole and we have a blue pole. As we have already seen that the lines of forces come out from here and enter into the south pole. Are you observing here that these lines of forces, when it is passing like this, it is almost vertical at this place, almost vertical at this place, and it is horizontal at this place.
Yes.
This is an important understanding. These two are called poles. So we have red pole, blue pole. So what we are observing at the poles, these magnetic lines of forces are emanating vertical or entering vertically into it. On the broadside position, these magnetic lines of forces are horizontal to the surface. Broadside position, horizontal, end-on position, vertical. It naturally says that there is an angle at this place with respect to the horizontal. There is an angle. The lines of forces are not at zero, not vertical 90-degree, but other places it will be some other kind of angle. Remember this. This information to be remembered very, very closely, that at broadside position, the lines of forces are horizontal. At poles, they are vertical. Remember this, because this will be required for further understanding.
सर एक बार रिपीट कर देंगे सर, वो कनेक्शन चला गया था.
Okay. What we said, magnetic lines of forces, flux density वगैरह सुना आपने?
यस सर, वो सब सुन लिया था.
Okay. So what we said, an important information that we are right now discussing is that if this is the red pole and the other end is blue, मान लीजिए इसको blue से ही मान लेते हैं. Lines of forces are coming out from here and entering into this. Since this is remaining to the north of the earth, so we call it north and south pole, yes. But observation that I need from you is that at this pole, these magnetic lines of forces are vertically extending or emanating. At this place, it is vertically entering into this pole. At this place, these are parallel to the surface. So broadside position, it is parallel. At poles, these are the poles that we are talking about. At poles, it is vertical. So this information is important for you. आगे की understanding.
Okay, sir. Thank you.
Another thing that I want to add, अभी बताया नहीं था, adding up, is that if it is horizontal, if it is vertical, that means these lines of forces are changing from 0 degree to 90 degree, from reaching from here to here or here to here and here. This means this is at 0 degree here horizontal, here it is 90 degree. That means somewhere here it will be in between these two values or not?
Yes, sir.
Yes, it will be. So this information is also important as we are going to discuss further. Talking about the Earth's magnetism. अच्छा, एक चीज और बताना. If we have this magnet here, if we have the magnet here, which is having a magnetic field, if I bring in another magnetic material, these lines of forces pass through this, and this also becomes a magnet. This also becomes a magnet. How come? Since the red line is coming into this and it is passing through this, so if it is becoming from this end to this end, which this end will become what? Inside, if the lines of forces are passing, this end will become what? Which kind of pole?
South. South.
Very good. So this end becomes south and this end becomes north. Similarly, if we had this one as ulta, then the lines of forces will be passing through this. In doing so, this end will become red and this end will become blue. So this has turned into a magnet, and this is the magnetism. That is the pole creation of this. Incidentally, if we want to magnetize it, and we have kept it like this, very good, this north-south pole has been made, blue and red pole has been made. Incidentally, if we keep the same material like this, same piece of material like this is not magnetized. Whatever magnetism is going to be appearing here and here, that is kind of insignificant. If we have an iron which is perpendicular to the lines of forces, then magnetism is 0 or minimum. Only when this material is in line with the magnetic lines of forces that it is having maximum magnetism. Induced magnetism maximum when in line with the lines of forces. Perpendicular, magnetization 0. So do we have some concepts about this magnetism?
Yes.
Yes.
Another thing, most of the things, as we have already understood, is iron On the ship, the ship's iron, or any iron for that matter, can be described as hard iron and soft iron. The difference, what is this meaning of hard and soft iron? तो जनरली आपने एक्सपीरियंस किया होगा, कुछ तारे वगैरह होती हैं, आप उसको मोड़ते हैं तो जल्दी मुड़ता नहीं, और कुछ को मोड़ते हैं तो बड़े आसानी से मुड़ जाता है। मोटा भी होता है तो भी मोड़ पाते हैं उसको, कुछ पतले होते हैं फिर भी नहीं मुड़ता। फॉर एग्जाम्पल, यू कैन ऑल्सो मेक एन अंडरस्टैंडिंग ऑफ दिस बाई अ स्प्रिंग। स्प्रिंग पतली सी होती है, उसको मोड़ने जाइए उस वायर को, नहीं मुड़ता। नॉर्मल सीजिंग वायर आराम से मुड़ जाता है। सो द प्रॉपर्टी, फिजिकल प्रॉपर्टी इटसेल्फ इज हार्ड एंड सॉफ्ट। एक हार्ड होती है, एक सॉफ्ट होती है। बट फ्रॉम द पॉइंट ऑफ मैग्नेटिज्म, these hard iron are those iron which are difficult to magnetize. These are difficult to magnetize, but अगर उसको मैग्नेटाइज कर दिया, then it becomes permanent magnet. That means now it is, once it is magnetized, then it will remain magnet for the life of it. उसको डीमैग्नेटाइज करना मुश्किल हो जाएगा। बन गया मैग्नेट तो बन गया। नॉर्मल केसेस में उसको डीमैग्नेटाइज भी करना पॉसिबल नहीं हो, अनलेस अगेन यू एम्प्लॉय दोज मेथड्स, हीटिंग इट ऑल द वे, रेड हॉट करके उसको गर्म कर दिया तो डीमैग्नेटाइज हो जाएगा। But hard iron is basically leading to permanent magnet. Soft iron, on the other hand, is easy to magnetize. फटाक से वो मैग्नेट बन जाएगा, but equally easy to demagnetize. एक तो आराम से मैग्नेटाइज कर दे सकते हैं उसको, जैसे ही मैग्नेटाइजिंग फील्ड हटाएंगे वो डीमैग्नेटाइज भी हो जाएगा। दिस इज द केस। एक एग्जांपल दीजिए वेयर वी यूज दिस काइंड ऑफ सॉफ्ट आयरन। अभी हमने डिस्कस भी किया था।
inside solenoid.
Solenoid is nothing. Solenoid is a shape. This
No,
is a
sir.
solenoid.
Inside a solenoid, we put soft iron bars.
Yes, but for what purpose? Very good. You are right. When we want this bar magnet or this material to become magnet, we want this magnet when I pass the current तो मैग्नेट हो जाए, जब हटाओ तो डीमैग्नेटाइज हो जाए। तो सॉफ्ट आयरन इज नॉर्मली पुट इनसाइड द वेयर वी रिक्वायर इंड्यूस्ड मैग्नेटिज्म ऑन फिंगर टिप्स। जब चाहे तो मैग्नेट, जब चाहे नहीं मैग्नेट। रिले जो मैं सुनना चाह रहा था आपसे वो था रिलेज। स्पेशल रिक्वायरमेंट ऑफ दिस इन द रिलेज। Easy to magnetize, easy to demagnetize. Current हटाओ, demagnetize. Hard iron, of course, armatures, coils के generators में हम यूज करते हैं, motors में यूज करते हैं। We can use permanent magnet, तो वहां पे हार्ड आयरन की जरूरत होती है। तो ये तो रिक्वायरमेंट हो गया कि यहाँ पे मुझको ये चाहिए, वहां पे वो चाहिए। Different applications, different needs, and we work around getting what we want one way or the other. But on the shape, the whole thing is iron. The accommodation is iron. The cranes are iron. There are derricks which are iron. The hatch covers all iron. There are pillars which are iron. There are beams which are iron. There are girders which are iron. All over the place it is iron. This iron in the shape could be either hard or it could be soft. So ship's iron can be either hard iron or can be soft iron. The hard iron of the ship will lead to permanent magnetism. Soft iron will lead to induced magnetism. Why? ये शिप क्यों मैग्नेटाइज होगा भाई? शिप तो इतनी बड़ी सी चीज है. Why should it get magnetized? ये हार्ड सॉफ्ट की बात शिप में कहां से आ गई? वो बार मैग्नेट तो हम समझते थे, छोटा सा लोहा का पीस लिया तो हो गया. But you should remember that when the ship is getting built, she is in the Earth's magnetic field. That means there is this Earth's magnetizing field. There is this Earth's magnetizing field which is passing through this iron, which may be soft, which may be hard. When the ship is getting constructed, she is in this orientation, this situation for long period of time, maybe years together. 2 साल 3 साल में बन रहा है जहाज. 2 साल 3 साल तक कंटिन्यूसली एक मैग्नेटाइजिंग फील्ड लगे जा रही है. मीनवाइल हम किसी चीज को हॉट करते हैं, वेल्डिंग करते हैं, वो जब ठंडा हो रहा है उस समय मैग्नेटाइजिंग फील्ड सारे मॉलिक्यूल्स को सेट कर रहा है अपनी तरफ से. हॉट है, इट इज इन molten state, molecules are free to kind of move. In that there is this magnetizing field sets them aligned in that direction. So finally, when the ship is built, there is permanent magnetism of the ship becomes a permanent magnet. Some of the parts put together, joined together, turn the ship into a permanent magnet. But some of the things may be soft iron, which is right now showing some kind of magnetic properties, but जहाज को घुमाया तो ये मैग्नेटाइजिंग फील्ड का इफेक्ट इसके ऊपर से खत्म हो जाएगा या चेंज हो जाएगा. लेकिन जो परमानेंट मैग्नेट बन गई वो बन गई. Now so there is probably, for example, one end of the ship is acquiring one pole, the other end is acquiring other pole. So will there be magnetic lines of forces passing like this? अगर शिप बन गया परमानेंट मैग्नेट ऐसे, तो लाइंस ऑफ फोर्सेस होंगे या नहीं?
यस सर,
Yes,
होंगे.
sir.
और आपके ब्रिज पे यहाँ मंकी आइलैंड पे कंपास बना हुआ है, तो these lines of forces will be passing through the compass.
Yes.
Yes sir.
So that means this will get affected. A compass is nothing, remember, a compass is nothing but a piece of iron which is basically a magnet. ये कार्ड के नीचे में लटका देते हैं, कार्ड में लिखा होता है 000, 090, 180. This सस्पेंडेड ऑन अ पिवट, ये हमेशा घूमता है ऐसे. So this is nothing but a magnet having some special design for the purpose that we are using. So यहाँ पे basically कंपास में एक magnet है. So this lines of forces, they will interact with this magnet or not?
Yes, sir.
इसका अपना magnet है. Now these two magnets will interact with each other. And when they interact, अगर दो लोग लड़ेंगे तो धक्का मुक्की तो होएगी. जो कमजोर होएगा वो पीछे धक्का होएगा या साइड में धक्का हो जाएगा. जो मजबूत होएगा वो जीतेगा. अनलेस कि जो कमजोर है उसकी सपोर्ट के लिए कोई दूसरा उसका फ्रेंड आ जाए. सही है ना. तो ये बड़ा मैग्नेट दिखता है, इसका इफेक्ट इसके ऊपर ज्यादा होगा तो डेफिनेटली दिस विल गेट अफेक्टेड. ये छोटा बच्चा लग रहा है. When it is getting deviated, he wants some friend, so he gets another friend. What is there? Something called corrector magnets or corrector devices. तो ये अपने साथ दूसरे मैग्नेट्स को ले आता है और इनसे लड़ता है और इनकी बराबरी कर लेता है कम से कम, ताकि इसको डिस्टर्ब ना करे. जो कंपास के करेक्टर्स के मैग्नेट्स के का जो कॉन्सेप्ट है, इट इज दैट. So are we good up to this?
Yes, sir.
Okay, so what we will do, we'll go through the slides. Probably some of the things that I have missed while speaking extempore, तो वहां पे कुछ नजर आएगा, कुछ ऐड करेंगे, कुछ वहां से उठाएंगे. Allow me to share the screen and we can go to the PPT slides to review what we have just done. वैसे और भी चीजें आएंगी, but we will see how it goes. So allow me to share the screen. Just 1 second, let me find out the file. Just 1 second, getting to the last slide. All right, so here we are. So we are at this place somewhere. So few of the terms and definition which are used in case of magnetism is what we are going to review. Magnetic dipole. What is this dipole? A pair of magnetic poles, equal and opposite in nature, separated by a finite distance, is a magnetic dipole. Dipole means two poles. There are two poles equal and opposite, finite distance away. That means this is a magnetic dipole. So since we have been seeing it multiple times, a bar magnet has got a red end and a blue end, which is separated by a finite distance. That means this is a dipole. Next, magnetic dipole moment. A vector basically That means it must be having a direction, must be also having a magnitude. So it is a vector running from south to north pole. South to north pole. Remember that the magnetic lines of forces were also running from south to north. So it is in the same direction of lines of forces along the axis of the dipole with the magnitude which is 2 into distance and the pole strength. So if the pole strength was m and the distance between the two is L, then magnetic dipole moment M is M into 2L. It would have been only L if there was one pole. But since there is a pair of poles, so these moments get doubled up. Basically, M is the pole strength, that means it is a kind of force, and L is the distance. So we know about torque or moment. Moment is something when we apply, if something is free to rotate about an axis and we apply a force away at a distance d, if a force is applied at a distance d, then it begins to turn the object around its axis. F into d is moment. The turning effect. So here also what we are saying is the same thing. It produces a turning effect. Why and how? बाद में देखेंगे. Then what is magnetic field? हम लोगों ने बोर्ड पे डिस्कस किया. It is the area around the magnet or dipole where a force is experienced by another magnetic material. That means there is a magnetic force which is exerted on another magnetic material. As we have already understood and discussed that these fields are represented by lines of forces. These are imaginary lines of forces, always parallel in the sense always cushioning with each other but never intersecting each other, coming out from the North Pole, getting into the South Pole outside. But inside it is from South to North Pole. We also have seen that it is vertical at the poles and horizontal at the broadside position to the magnet. So that is magnetic field. Again, remember, these are imaginary lines of forces, not that it is existing there in the form of lines. Next, the broadside position and end-on position concept. Tell me if everything is fine here and we understand this. Important understanding.
Yes.
So if it is x here, as we said, if it is x here, here will be 2x and 2x. There will be x here. The field strength being x. Next, what is magnetic flux? These are those lines of forces. Clear what you're reading?
Yes.
Accepting that Weber is the unit of this flux. Flux is all these lines of forces basically that we are talking about. Weber was of course a scientist, उन्हीं के नाम पे ये नाम दिया गया unit 1 Weber. So if a north pole is unit north pole, then it is radiating 1 Weber of flux. Then flux density B, it is the flux per unit area. Given area में कितना flux है, that is the flux density. Then we talk about the field strength H. How much of force will be exerted on a unit pole? If I have a red pole in my hand, there is another magnet there, and if I keep this red pole at a distance of so and so, then what is the force experienced by this? How much of pull or push, repulsion or attraction is going to be experienced by this unit pole? That is the measure of the strength of the magnetic field. What we are saying, if we have a magnet, there is lines of forces, I keep another unit pole here, this is going to get pulled or repelled depending on the polarity. What kind of force it is exerted or exerted upon? The force experienced by this is the field strength. It is natural to understand that the strength will be more here and less as we go away. And it is also very intuitive to understand it is more here because more number of lines are there. Flux density is more here, and as we go out, the flux density is reducing. So that is flux field strength, and it is given by m into h. That means जो पहला magnet था उसका pole strength is m. The force experienced will be the strength into the pole of the magnetic pole m into h. नेक्स्ट हार्ड आयरन के ऊपर आएंगे हम, सॉफ्ट आयरन के ऊपर भी आएंगे. हाँ, एक चीज और, ये सब थोड़ा सा ये भी पढ़ेंगे. एंड इंटेंसिटी ऑफ मैग्नेटाइजेशन, व्हाट इज दैट? If we have a soft iron which we are bringing in the field of a magnetic magnet, then it becomes a magnet. The soft iron becoming magnet. So how much of magnetization is going to happen? That is the intensity of magnetization. अगर फिर से वही बात कि हम दूसरे मैग्नेट के नजदीक में लाते हैं जहां फ्लक्स डेंसिटी हाई है, तो इंटेंसिटी ऑफ मैग्नेटाइजेशन इज मोर. If we keep it away from the magnetizing field, then the intensity of magnetization is less. What we are saying, okay, I have seen that the time is up, but if we keep the magnet here, magnetizing field, there are lines of forces like this as we go out. If we keep a soft iron here, the magnetization intensity is less. If we keep it here, it is more. the orange bars of soft iron are getting magnetized. By what? How much is the magnetizing? Intensity is what is experienced by this and what is experienced by this. So these are different terms that we use. So we'll talk about this in the next class. We have the fourth class also before lunch. So we'll come to this topic once again and we'll take it further. For now, I suppose we should stop the class and say bye-bye. Before that, any questions? Any questions, gentlemen?
Negative, sir.
No, sir.
Okay. Then we'll take a break. We meet again at 12:45. Bye-bye. Have a great day.
Bye, sir.